Welcome to Science Matters Colorado, the podcast that explores the environmental issues shaping our beautiful state. I'm your host, Alex Ippenhammer. Each episode, I talk with experts to help you understand the challenges we face and celebrate the natural wonders we strive to protect. Today, I'm talking with natural builder Tim White. I met Tim at the Crestone Energy Fair in Crestone, Colorado, an eclectic town where I was introduced to natural building materials and techniques. Tim has been in the natural building industry for almost 30 years. During the fair, Tim gave a talk on clay plasters, and I was hit with more truth bombs about the built environment in that one talk than I had been up to that point in my life. All of it made intuitive sense, and Tim clearly had a plethora of knowledge to offer on the topic. Backed by hard science through his studies in anthropology and archaeology, Tim distilled many health and environmental issues down to a simple dichotomy: conventional building materials versus monolithic organic or natural building materials. Our conventional wisdom tells us that modern materials are durable, reliable, and safe. In fact, conventional building materials are toxic, highly combustible, and create over 30% of the world's waste. The archaeological record shows that humans have used natural building materials for millennia. Their use is circular, sustainable, better for our health, and aesthetically pleasing. In fact, the techniques that Tim describes in this episode create temperature and humidity controlled environments that are livable without the use of a thermostat. I invite you to stoke your curiosity at the hearthside of Tim's abundant wisdom on the benefits that natural building brings to humankind. Please enjoy. For those who aren't familiar, what is natural building in a nutshell?
What natural building is historically used, low carbon footprint, locally sourced building materials, that have a local or regional base to them. Once you go in that direction, we start to use historic based materials that have been used for centuries by humans. And we get to the point of when we look at that, it's like, wow, these are actually low carbon footprint building materials. When you look at straw bale or adobe or compressed earth block or light straw clay type of systems, a lot of them would go into a timber frame type of a building historically. And so that was all local source based materials that weren't being shipped from around the country. The beauty of it is once you go down to those natural building materials, you also start to cut out all of the petrochemicals that are used in the conventional industry. And so as we move forward, as a society, moving back in that direction does a couple of different things. It creates a circular economy, and it starts to create healthy buildings. And another thing that it creates is energy efficient buildings, because natural building materials are really good with controlling humidity and temperature. And so when we start to look at it, it's a win-win-win type of situation.
It's such an ideal medium with all of those benefits that you just named. And it really raises the bar for sustainable building and design. But it's actually pretty rare, to the point that the average person in the US probably isn't familiar with or hasn't stepped foot inside of a natural building. Yet, as you said, natural building materials predate modern society because they're natural and locally sourced materials that indigenous peoples would use. So given how rare they are in the building industry, how did you first get involved with the natural building?
My first experience with it was when I was leading a cultural immersion wilderness trip for a group of teenagers with a company I worked for on the Hopi Nation. And we were doing some service work in their Kachina Plaza. And as one of the supervisors of them, I was talking with the other supervisor from the community, this lady. And she's like, oh, we need to masonry these stones back in that, during our last dance, they got knocked loose and everything. And so there were 3 Hopi men up on top of the Pueblo that were working on a earthen roof and doing some repair on it. And they had made me up some mud, and they had given me a trowel, and I started putting it in and laying it together. And the Hopi men, hollered down to her in Hopi, and I was like, what'd they say? And she goes, they said that you've done this before. And I said, I've never done this in my life before. And so she yelled that up to that answer to the Hopi men on top of the roof doing the repairs, and they started belly rolling. They were just like laughing like they was crazy. And then they yelled something down in Hopi to her. And I was like, what did they say? And she's like, oh, they said, maybe not in this life. You haven't done this yet, but you've done this before. It wasn't until I got back up to Southwest Colorado 6-8 months later, trying to figure out what I wanted to do. I had known from my other experiences in life that I didn't want to go into conventional building because I knew what was involved with it, the toxins with it, the environmental effects it was having. And so I reached out to a guy who was trying to start a contracting company, got him hired on a straw bale project. At that time, the biggest straw bale project in Colorado, a big 3,600 square foot monstrosity, as a laborer, making $7.50 an hour. In the 90s with 2 college degrees and honorable discharge from the Marines just to get experience with it, And then we got to doing the plaster work, and they hired a Hispanic stucco crew to come in, and they were covering it all with cement. And I was like, this is the wrong thing to do. And the contractor's like, if there was another subcontractor out there that could offer a clay or a lime plaster finish to this and a number for it, then they would get the job. And being young at that point in time, I was like, this is an opportunity. And so I dove into doing different clay plaster workshops and stuff like that, and doing lots of experimentation on my own to get an understanding of the material. I even built a little building so that I could plaster it so I could see what was taking on with it. And then got hired on with another group of builders that were doing work on owner-builder projects in a community called Heartwood Co-housing. And we did 4 or 5 different buildings over a number of 3 or 4 years, all the way from light straw clay timber frame projects to a straw bale duplex. At that time, I was like, okay, this is working great. I started to see that we needed to do something better than clay plasters on the outside. And so I started to dive into lime plasters. I started to do research with my archaeology degree and meticulous note-taking with my field biology degree, and really started to figure out what type of lime and pozzolans were in the area and what was that about, and started to source different ones that I really liked. And with that, I became intimately involved with lime and pozzolan reactions through that whole process, and to the point right now where, I've got different lime and pozzolans that I source that create basically Roman concrete. And so we've been using those to make hydraulic limes for all of our plaster systems that we do. We haven't gone to the direction of using it as a foundation because the amount of testing needed for that is not there yet.
Your talk from the Crestone Energy Fair about clay plasters was very revelatory in terms of all the health benefits of clay plasters. And it was the first time I really learned about the VOCs, the volatile organic compounds that are contained in, the paints and a lot of materials that are used in building. But going back before that, your background is it anthropology, biology, and then you did like a graduate degree in archaeology?
No, I do not have a master's degree. I have 2 Bachelor of Arts degrees.
2 bachelor's degrees. Okay. And are those the 3 content areas? Is that right?
The main content area is biology with an emphasis in field biology, and anthropology with an emphasis in archaeology.
And that has informed, as you were saying, your work as a natural builder because you did more research in lime plasters. Did you help develop a type of lime plaster that could be used on the exterior?
Yeah, we use that when I work on projects instead of importing it from Europe. Another thing with my background of being a veteran in the military is I want to support American-based materials because that supports American-based economy and American workers. In the time that I was in the Marines and the 10 different countries that I went, and had friends not come back, it's like, if we're not going to do that, then what was that all for? This has kind of been my moral driving compass, as well as through field biology, degree, really starting to understand what we were doing to the environment. And through the archaeology aspect of it and that research-driven focus is these houses that are still thousands of years old that are standing, what's taking place with them? Why are they still here? When do they start to fail? And I took a historic lime masonry course with U.S. Heritage Group out of Chicago. Back in 2007, and really started to get an understanding of what was taking place inside of the sand gradation, inside of it, what was taking place on these old buildings, because they were showing photos of buildings that were just covered with latex paint. And within 3 or 4 years, they were starting to mold out. And so that begs the question is, if you're a conscious person and you look at that, it's like, oh, okay, as long as we go down this path with natural materials and live by that philosophy, we're going to be making buildings that are going to start to last for hundreds of years instead of buildings that are going to last for 50 to 70 to 80 years, which is what we're making today.
There's a lot of talk of green building, and I recently went to a talk in Lafayette about one of the buildings there, which they said is one of the greenest buildings in the area. But natural building is different. What are some key differences between natural building and green building?
I was involved with an organization called the Southwest Natural Builders Guild at the turn of the century. And that's when green was starting to come in the 90s and everything. And there was a group of us, natural builders, that were like, we need to define the difference between natural building and green building. Our green building will just encompass us. Okay? 20 plus years later, that's exactly what has happened. To the point now that if you ask somebody what green building is, sometimes they will say it's a natural building. Well, green building is centered around lower VOC than what we had in the 80s for paint products and stuff like that. Better, tighter insulated building envelopes, which is great because it increases energy efficiency. LED lights, energy efficient appliances. But when you look at the green building systems, especially with like the stucco systems, it's the same exact materials that they were using in the 80s. We might have a lower VOC paints as far as interior, but it's basically the same sort of building materials that we were using, and they just started focusing on more energy efficiency to make the building greener. Okay, they've been able to manipulate that to the point where when I talk to some people who you would think that we're conscious in the hemp movement, and they're like, well, green building is natural building. And I was like, no, it's not. I had an architect who, she's an older lady now in Austin, and she was a green builder, and green designer. And then she went to a natural building cob workshop type of a thing. And she came back from that completely changed. And she was like, green is not natural. What natural building is it is a step up from green building. Okay? And when we were first introduced in the 90s around green building, and everybody was going out there and doing the green programs and then the LEED programs, they were like, green building is not the end all of end all. This is just a step to get us going in a different direction, mainly around energy efficient, lower VOC products and stuff like that. But now, 20, 30 years later, we haven't seen the green building programs come up and say, hey, it's time for us to step up and actually look at natural building and look at now what's the carbon footprint of the green products that we're using. That's really that next step, is to like look at what is the carbon footprint of the whole house. Green building really doesn't take into account any of that, and the LEED programs, they're really mainly focused around daylighting, energy efficient design, energy efficient leadership in energy and environmental design is what kind of LEED stands for. So it's still not addressing the carbon footprint of the building materials and the carbon footprint of the building. And both of those programs are not even looking at the type of toxins that are in the conventional building materials that are being used inside of the building envelope, And so that's where those programs are falling short. To where I always say that green is not natural building, but natural building is green.
Right. Yeah.
And so they can get twisted, and when they get into marketing programs and stuff like that around it, the green building programs have no problem grabbing onto the coattail of natural building and saying, hey, this is a natural building system and it's really green. We're not really looking at where those products came from, what's the carbon footprint and the embodied energy inside of those products, and we're definitely not looking at what are the toxins and the chemical composition of green products.
Right. So it's a step in the right direction, but it's not as big of a step as natural building. And a lot of natural building is focused on the materials, which you've been mentioning in terms of hempcrete, straw bale. Are there any particular materials right now that have you excited? It seems like hempcrete has been growing in terms of more people using it, but I could be wrong. Is there any material or technique that you think could potentially revolutionize the building industry, or maybe not to that extent, just something that you personally feel is a exciting or great material in natural building?
There's a lot of different levels on that, Alex.
Mm-hmm.
Okay. You know, a low-hanging fruit is just keep doing conventional building and go to putting a hemp bat insulation inside of our wall cavities for insulation. And then over the drywall, we use clay plasters instead of latex paint. You know, that would be beyond anything that green is doing in their conventional building today. Okay.
What is hemp bat?
It's like a replacement to fiberglass insulation.
Okay. That's not the same as hempcrete, though?
No, it's not.
Okay.
It's made with the fibrous material of the plant to make an insulation that's a replacement to like foam sprayed in material, or the Owens Coins, the pink fiberglass insulation. And that can get replaced immediately inside of that wall cavity. You can still do drywall because there's lots of drywallers out there, but we just switched from doing latex paint to doing clay plasters. You know, and the clay helps control humidity and temperature. It doesn't have any VOCs in it. And that's a super low-hanging fruit for a conventional builder to take that next step up to incorporating more natural materials inside of the building envelope. A hempcrete block material that can go into a stick frame system, you know, and then it gets plastered. Well, now we got rid of the drywall, you know, on the wall systems. The system that I have the most hope for out there is using a adobe or a compressed earth block size hempcrete block, you know, that becomes lightweight. We get our insulation value. I've built 10 buildings off of a papercrete system, which was a papercrete block, which was concrete and 65% waste paper, but it fit the Adobe building code for structural load. But instead of weighing 35 pounds a block, it weighs 18 pounds a block. The company that was making them is no longer in existence, you know, but they were something that could get shipped right to the job site. There are a couple of companies, one in Colorado, that is taking the lead on what I've been saying is, you know, if we can get a structural hempcrete block, you know, that meets Adobe building code, now we can just stack that in a historic lime mortar and we can get rid of all the framing material that we would need in a conventional building.
There is a company doing prefabricated hempcrete blocks in Colorado?
Yep, hemp and block.
Block?
Yeah, and right now they're mainly focused on a block that would go into a post and beam or timber frame, or a block that would go in between 2x4 studded walls or 2x6 studded walls that you would plaster. And then out there in the world, there's the hempcrete system where it's a cast-in-place system that's mixed on site. It's wet. You cast it into formwork, and then it has to dry. That dry time is really killing us as our completion on job site, you know, and trying to get it so it dries. And so these hempcrete blocks are really exciting because they could go into a conventional frame building and have your sheeting, and it looks just like a track home in the Front Range of Colorado on the outside, you know, vinyl siding or whatever. But for the insulation, we're taking this hempcrete block and we're putting it in between the 2x4s and mortaring it together. That gives us our insulated value. It gives us our substrate that we can do our lime plasters on the inside and then transition to clay plasters. And so it is, those are the creative ideas that we need to go in that direction of how do we get some of the materials and the process of these conventional materials out of the building envelope that are giving us all these problems with mold.
Would aircrete fall into that category? Is that kind of more of the green building material?
The aircretes have a Portland cement base, and then it's an air that is infiltrated into it, and that Portland cement has enough structure. The reason I don't like the Portland and the aircrete system is that we're still using that high carbon footprint Portland material, you know. And the only reason I was building with the papercretes is it was a block that I could get. I didn't like the fact that they had the concrete in them, but they were still 65% waste paper. And it allowed me as a builder to be able to get them stamped by engineers to be used in coated areas in southwest Colorado, small little towns and stuff like that. And it was also a way for me to show as a prototype that a weight-bearing cellulose-based block, a structural cellulose-based block, is an alternative out there in the marketplace. You know, it's a prototype. I mean, we got 10 of those buildings that we've done over the last 15 years, and all of them are performing amazingly well. That being said, though, they've got exterior lime plasters, and they've got interior clay wall finishes in them.
Are these types of building materials suitable for all climates? Because Colorado is generally like a pretty dry state, and I feel like I see these materials being used in places like, you know, New Mexico, Crestone, Colorado, Southern California, some places like that. Can they be used in a climate that is higher humidity, gets more precipitation? How do they hold up in different climates?
Natural building materials have been used in pretty much every climate that's out there. One good example is that when we were building with compressed earth blocks, and I know other compressed earth block builders out there, it's like an adobe, but it's a rammed adobe instead, is that once we get over 7,000 feet in elevation, we get nervous about that mass cooling too much because it's a lot of mass. And so once you get to that elevation, some sort of insulated material would be used on the outside. Once you go to the hempcrete and the straw bale, now we're dealing with a monolithic cellulose-based block that can deal with a lot of temperature swings. You know, the oldest straw bale house is built out on the prairie in Nebraska, and it gets pretty darn cold out there on the prairie in Nebraska, you know. The Vikings, with their lodges that they would build, you know, they were 3 feet of earthen material. And so they understand that when they went smaller with that wall, that they were going to get more cold coming through. And so they did really big, massive exterior walls that time lag took a long time for that cold air to get all the way through. You know, and so those are more the things that we see when we get to using heavy mass materials in colder climates, is we need to insulate that exterior some way. When we get to humidity zones along the Gulf Coast and stuff like that, we're more concerned about how do we make sure that we don't get moisture buildup inside of that space. And so we make sure that we have good air exchange systems. We make sure that we have ceiling fans so that we can get good air movement inside of the building. The amazing thing is, though, that the natural earthen-based building materials, organic cellulose-based building materials, are really good at controlling heat and humidity inside of the building envelope. On the picture that we're going to show later around the Hondo Project, you know, it was 105 degrees outside, and we had the windows open, and it was 78 degrees on the inside, to the point that when the air came through, when you're on the other side of the house, standing next to that window, there was a cool breeze coming out of that window, you know. And in that one, we've got a dog trot breezeway through it, 105 with air coming in from the south. On the back side of it, of that breezeway, it's 82 degrees, and it's a nice cool breeze, you know. So not that 82 is cool, but it's not 105, you know. And so what I find inside of natural building and designs in different areas is making sure that that wall system is protected with a good overhang on your roof system, you know, and a good set of boots, a foundation that comes up out of the ground. We're really wanting that foundation material where that hemp wall starts or that organic wall system starts 10 to 12 inches above the finish grade of the building. And you can see on the Hondo Project on the left, we've got the breezeway. This is the north side of the house, and so we've reduced the amount of windows that we have on the north side. The south side, we've got good passive solar design. Where the mini split system is and the electrical box, that's the west side of the house. You know, and so we really want to reduce our west side window glazing, because that just becomes an oven in a lot of climates, you know. That, and so that is kind of the features of this building, you know, on the left. It's got good overhangs all the way around it. We've got a good set of boots. We've brought our foundation up out of the ground. There is a lot of extra expense in a house to do that. And so in a lot of conventional homes that you see in tract homes, you know, their foundation is 2 or 3 inches above where the bottom plates of the house are. They've got a 6 to 8 inch overhang so that water splashes right up into the wall, comes down, and then it can wick back up inside of the house. And it's so airtight that when water wicks up inside of it, that moisture can't get out, and then we start to get our mold growing inside of the building envelope. You know, on this particular...
So that extended overhang is just something that basically all buildings should have to prevent that moisture from wicking, is what you're saying? It's not just a feature of natural buildings?
No, and that's how a lot of the older houses that were built in the 1800s, early 1900s, before we got into the tract homes, you know, they all had decent 18-inch, 2-foot overhangs on them, because they knew back then that if we can give it a good hat, get that water pushed away from the wall, it's not going to splash back up into the wall and absorb and condensate there. We're also going to get less wear and tear on the wall system. In natural building, a lot of our natural buildings that are done with do-it-yourselfers and stuff like that are clay plasters on the outside. And so they want to incorporate an overhang or more of a wraparound porch to protect that clay plaster, because, you know, your clay plasters are not going to hold up as well as the lime plaster that's on this house. And then when we go to the interior of this house, that's all adobe floor. All 2,400 square feet of that house inside of there is adobe floor. And so we were able to get rid of the concrete and the reinforcing steel inside of the building envelope, which is a lot of carbon that you don't need to use to build the house, you know. And that's kind of a focus I've always had, is how do we get to the point that we can reduce the carbon load of the house? A lot of times it's measured in British thermal units. We did a calculation on this house through a book called Living Spaces, looking at cob and what that carbon footprint was per British thermal unit compared to reinforced concrete and steel. We took over 7 million British thermal units of energy out of this building just by switching from a concrete slab to an adobe floor. You know, because
okay. Do you still have a Portland cement foundation?
Yes, we still have a Portland cement grade beam. I think on this house for our grade beam we used 28 bags of concrete instead of...
Doesn't seem like much at all.
No, normally not. And the amount of rebar we used was minimal because we don't use any rebar. I mean, most concrete slabs, you know, they have rebar on foot square grids throughout this. I think we ended up using 45 pieces of rebar on this whole project. And that grade beam...
And that's because the hempcrete isn't load bearing. Is that...
Right. The hempcrete on this system is not load bearing. It's built with the 2x4s that are screwed and nailed together. And then it comes up to a beam, and it's a double LVL beam that goes all the way around. And so that carries our structural load down to our grade beam foundation of our engineered truss package that we put on top of it. Another thing that I've always liked to do is this is called a hip roof system instead of a gabled roof system.
I like that.
So it brings down the exposure on our ends to all 9 feet all the way around the building. So we don't have a gabled roof that's 16 foot tall on two ends. When you go to a hipped roof system, it's also tied back into itself. So it's all at a 45 connections all the way through it. It becomes really, really strong. You can't twist it at all. And in this particular house, we wanted to show that that you could get rid of all the drywall in the house. And so on the right there, that wall behind that fireplace is a 9-inch thick hempcrete wall that's got a base coat of lime plaster and finished with clay plasters. And then we went to tongue and groove ceilings so that we could get rid of the drywall on the ceiling. This is something that we would do in Colorado and all the projects that I built up there with my company. Because down in southwest Colorado, the Aspen Tongue and Groove plant was just down the road, you know, so we could just drive down there and get the material. Another beauty in Colorado that we were doing when we were building straw bale and straw bale adobe hybrid houses is we would go with an engineered truss system. That engineered truss system is 2x4s and 2x6 wood that comes from a tree plantation. So those trees are being grown just for that material. It's small dimensional, so we're not cutting down old growth trees. And we would then contract with a mill in the area that would cut us 1x6 pine rough sawn that was being used in thinning programs to thin down the ponderosas. And we would replace our plywood or our OSB for our roof decking with that 1x6 tongue or that 1x6 rough sawn product that was made in Colorado. So in Colorado, when we were building, we got rid of all the plywood and OSB in the whole project, and it created local economy, and so that's one of the things that it's like, where do we go? Where are we moving? A lot of people have said, Tim, you're 20 years ahead of the movement. And I'm just like, this is just being common sense about what we have, trying to be focusing on creating local economic development and lowering the carbon footprint of the building materials. And when you start to do that and you go to natural materials, the amazing thing is you took the toxins out of the built environment also.
Yeah, I want to talk about the toxin aspect, because when you're talking about the moisture wicking and moisture accumulating, for me, I didn't know. I think we kind of just accept that mold grows in places that have high humidity, and that buildings aren't perfect, but it's actually a result of some very specific chemical processes. So, for example, when you're using clay plaster and you have hempcrete walls versus if you have drywall and you're covering it in paint, what's the difference between these two builds, and why is one conducive to toxic mold growth, whereas natural buildings sort of eliminate that potential?
It really gets down to, at the end of the day, is moisture allowed to get into the building envelope, and when it does, can it get out? Okay, the modern construction industry has really gone down the path that we're going to do everything in our power to keep water out of the building envelope. Well, first off, that is impossible, okay? Because at some point in time, it's going to condensate and get inside the wall cavity. Now, we've done a lot of house wraps and vapor barriers on the outside to keep that water from getting out or getting in from the outside. And then we've come onto the inside and we've applied latex paint over top of all of our drywall. And so we've got a system where when moisture gets into it, it can't get out. There's other properties that take place in bathrooms and stuff like that, and cold. If you got a cold ceiling, your water's going to concentrate on your ceiling or floor. It'll be on the ceiling. If you got a cold ceiling, it'll concentrate on the floor. And then we get into our bathroom spaces and we create all this humidity, and we try to make a bathroom fan that's going to blow that humidity out if you have it. But what happens is that moisture condensates, that wall is cold, so the moisture condensates on that wall. And if that latex paint has a scratch in it or a pinhole in it, it's going to migrate in through that little pinhole and get into the drywall. The drywall is a perfect medium for it to absorb moisture. And so it absorbs the moisture because it's a gypsum-based material, but it can't get released behind there because we've got a vapor barrier of our plastic paint over top of it. And then that's when we start to get our mold bloom. If we got a detail outside where our soffit is not draining properly and it drips and then it runs water back into it, gets in behind our exterior sheeting and our vapor barriers on the outside, and it starts to run down on the inside of that wall cavity, it can't get out. When you go to natural building systems and their natural-based materials, we're going also to a material that is thick in a monolithic wall system. It's solid, has a lot of organic-based material that can deal with that moisture a lot better. And when they're done properly with the historic clay or lime plaster on the exterior and the same on the interior, as long as they do not have a petrochemical sealer applied to them. Okay, we call it adulterated, As soon as it gets a sealer over top of it, now we lost our breathability, The beauty of clay and lime material is that They are always trying to pull moisture out of the wall cavity. They're actively pulling that water out of the wall cavity, or they're allowing that vapor to move through the wall cavity. And so it really gets down to, is it a hollow cavity system that doesn't have a whole lot of mass to it, and when moisture gets in there, it can't get out because it's sealed up? And going to a monolithic wall system where we've got a lot of body of that natural material that's able to deal with moisture getting into it and then allow it to get pulled out to the surface. A lot of people say, is the wall breathable? It really has to do with vapor permeability. Is it allowing vapor to move through it and not stop and condensate? Because when it stops and condensates, then we create a water droplet, and then that water droplet can fall, can condensate, or can accumulate at the bottom plate, and then it gets absorbed in heat, and we start to get the mold growing inside of it. That's the main, I think, basic 101 of building wall science, to tell you the truth. Does that make sense?
Yeah, that makes sense. What's something that people can do to optimize their health, considering a lot of buildings are built with volatile organic compounds, as you've named, like latex paints, drywall, caulk, I think you said is pretty hazardous to human health. I mean, are there simple things like, not everyone has the flexibility to build or move into a natural building, or even a green building for that matter? What can people do to optimize their health in those circumstances? And yeah, I guess I'm thinking the natural building offers so many solutions to these issues. It's just a matter of scale and getting the market to grow in that direction. But in the meantime, I know my brother, for instance, has lived in an apartment complex that just has affected his physical health because he thinks there's some mold growth or something that's messing him up. What can people in that situation really do?
First off is most of them are built with a forced air system. Make sure that you're cleaning your filters all the time, with that, so it's getting the particulates taken out of it. I even have a problem with that in my rental house that I have right now. I need to go change my filters too. When you get into an apartment complex, unless you own it, it's really hard to do a clay wall finish over top of that drywall. That would be the best thing that you could do. And American clay is a great American-based product. They don't have any funky synthetic additives in the product like some of the other products that are out there that are coming in from Europe. The beauty with the clay is that it carries that negative ionic charge, so it interacts with water vapor in your building envelope. It literally is cleaning your environment as it is absorbing water vapor and letting water vapor off. So if you have something funky on a water molecule vapor inside of your building envelope, when that clay absorbs that water vapor into the building envelope, it will absorb the water and then desiccate that germ because it starves that germ for water. So it actually has those properties of cleaning your air with germs and stuff like that, and mold spores and things like that, because mold really doesn't do very well if it doesn't have water. That's the beauty of life on planet Earth. If it doesn't have water, it's hard for it to survive.
Does that benefit of the clay plaster finish go away if there's already been a layer of paint to cover the drywall?
You're not going to get the full benefit of it being able to pull excess water through that latex paint. It's going to be very hard for it, but you can get that benefit of it going directly over top of it so that you get that body of that buffer inside of the building envelope. Once you've got your latex paint up, you're pretty much committed to the problem if water vapor builds up or water gets inside of your wall cavity. And that's why we're seeing so many problems in the conventional building industry. Because like you mentioned earlier, you see on the Front Range, houses going up left and right. None of those houses are built with any sort of craftsmanship whatsoever. They're all built with different subcontractors, and the other next subcontractor doesn't care about the next subcontractor or anything like that. And so what that has led to is super efficient systems, okay, for building. What it has not led to is the continuation of care in the construction industry for what's going to be the ramifications 5, 10, 15 years down the road for the occupants inside of that building envelope. And so that's a major hurdle that we need to deal with. If we're going to go back in a direction of building healthy, environmentally friendly buildings for people.
Yeah. In Crestone, you talked a lot about building codes and how Crestone has limited building codes, and a lot of people there are there because they have a lot of freedom to use sort of non-typical building materials and designs. What is an example of a building code that does a disservice to human health? Because you're very intimately familiar with building codes as a natural builder of 25 plus years of experience. Have you seen like specific codes that are detrimental to the health of occupants?
I would have to say that building codes that are detrimental to human health, the building codes are set up for health and safety at the end of the day for the people in the building, mainly focused around structural load going down, structural lift going up, and structural shear going sideways so the building doesn't fall on anybody's head. Then they've expanded it now to GFI outlets, within a certain area of a water source so that people aren't getting electrocuted. The one thing that building codes are falling short of inside of health and safety for its occupants is there's really no regulation around the building materials that are being used in the building envelope outside of weight bearing, lift bearing, and shear. So basically everything that's used inside of the building envelope with our modern materials, none of that is regulated around the chemicals that are inside of those products. We've gained some consciousness on it, but, there's been reports and there's 20 to 30,000 different chemical cocktails inside of a modern constructed house that we know are leading to health issues inside of the occupants inside of that building. And so that's the next step that the building codes really need to step up to and say, hey, we need to fund more research around these products and we need to start to outlaw certain products. There's been some regulation around the amount of formaldehyde that can be in different products, but we really haven't gone to the point of the paints. You've been in a freshly painted house, Everybody's gotten the headache from being in a freshly painted house. There are people that can't even go inside of a freshly painted house. Well, let's start to regulate that stuff, And so that's where, for me, as far as building codes being a health and safety issue, because that's what it's sold to us, right? As a health and safety issue, well, then let's really take that seriously around health and safety and start to look at the toxins and the chemical structures of the materials that we know that are hormone disruptors inside of people. We know that they're cancerogens. California has done a little bit better job with it than most states at looking at it and starting to ban some of those products. But at the end of the day, what building codes are is the minimum bar for building a safe, structurally safe building. It's the lowest bar that you have to meet. So that is kind of what we need to understand when it comes to building codes, is that the building codes are not the high bar for building. The building codes are the lowest bar where you need to meet. And a lot of us, I think, out there think that the building codes are all around the highest bar to get a structural building, and really they're all around the lowest thing that you need to create a structurally sound building. Now, as far as building codes in different areas like rural communities, Crestone's not alone inside of that, and inside of that county of having a looser building code. Montezuma County in Colorado in the southwest, the cities of Mancos, Colorado, Dolores, and Cortez, inside of the city, they've adopted building codes because they want to make sure that they're increasing their property value and everything like that. Whereas when you get out into the county, you're only really having to deal with an electrical code at your pole for your electric. Sometimes some counties have it so that you have to have an electric inspection inside of your house also. And really they're concerned around your septic system. And that's where Crestone is really bucking back around the septic system sort of aspect of doing a septic tank, because they're doing creative stuff around pasteurization of human waste, now. In Texas, where I'm building now, the city of Mason, Texas, that I live in, they've got a building code system, But when you get out into the rural communities in the county, they only have electric inspection at the pole and septic at the pole, or septic at the tank. In Hayes County, which is part of Austin, in the city limits of the town or the city in San Marcos and stuff like that, they've adopted international building codes. So everything is inspected. When you get into the rural parts of the county, it's still an electrical inspection at the pole, and it is a septic system at the tank, that you have to have as far as your permit process and signing off. I find it's more of cities and townships adopting the codes so that they can protect themselves from any legality that happens down the road with that building inside of the town. And when it gets to the rural community areas, if that county has not broadly adopted it through their county commissioners, International Building Code, it's still left up to the owners to deal with all of their structural stuff, because now that city or that town is not legally responsible for how you choose to build your house, and they pass the buck to the state or the electric company to make sure it gets inspected at the pole, and the state is going to want to have a septic inspection with the tank and a septic tank engineered for that soils, so that the state is protecting its watershed.
So if you could write a building code that every state had to adopt and in it eliminate one material, what would you eliminate from all buildings or homes? And what would you replace it with?
That's a loaded question. I think what I think would be the simplest, lowest hanging fruit that would give humanity a better chance of surviving and would change how the human body health is inside of it, of making latex paint or non-breathable paints illegal in houses and giving a tax break for clay plasters to be put over top of just drywall. It doesn't need to be an orange peel texture or anything like that. It can be a simple mud and tape the seams and then do a clay plaster that's not adulterated with synthetic binders, so that we get the full aspect of that clay then is able to pull the moisture out of that drywall if it gets in, because it doesn't have a latex barrier there, and I've seen it in projects that I've done that are conventional houses, and we tape and mud our seams, and then we do our clay plasters over top of it, and we come back a week later and it's like, wow, why isn't that clay plaster in that corner dry? It's because there's a moisture problem coming into that wall cavity. So we tell the contractor, he calls the roofer, and usually what they end up doing is sending a couple of roofers out with a couple of tubes of caulk, and they figure out where they didn't do the proper detailing on the outside, and they throw a bunch of caulk at it instead of actually addressing the problem. But the clay plaster over raw drywall will show you exactly where you have a moisture problem coming into the building, so that then you as a homeowner or the landlord are able to address that issue before it gets to where the whole wall is completely encased in mold, behind that latex paint. The fact that that clay carries a negative ionic charge inside of it, which is great for the human electromagnetic field. The fact that that clay is going to help buffer some of the humidity and moisture inside of that building envelope to help control humidity and temperature inside of the building envelope. That is where I think would be one start. And it's a funny question, because when I flew back east to see my daughter in college this fall, and I'm flying into Hartford, Connecticut, or when I'm flying into Charlottesville, North Carolina, or I'm flying into Chicago, I'm like, man, we could really change humanity's outlook and make it such a healthier place if we just had clay plasters inside of all these houses. We would develop a complete, get back to that trade, and it's super easy to learn the materials. And I look at it also inside of a skyscraper. If we were just putting clay plasters 2 credit card thick on all the drywall and replacing the sound panels with a coat of clay plaster over top of all the ceilings, that the sheer amount of humidity and temperature swing that we would be helping control would be saving millions of dollars in energy cost in a skyscraper every year.
Nice little segue into the question of scale for natural building materials. What do you think is the potential to scale these to larger developments? Because right now it's such a niche market and there's some limitations, but are those limitations just a matter of, consumer demand and consumer education and having more efficient processes for building with natural materials, for building with clay plasters? Or are there some other limitations in terms of like resource availability, in terms of time, in terms of cost for using these different natural building materials?
Well, first off, getting to the buyer of a home, very few owners and buyers of tract homes want to buy that house. It happens to be the only thing on the marketplace. Okay, so you're limited in your choice. They would rather have a building that's nature-based as a building material with more local source materials and that creates a healthy built environment. We get people reaching out to us on our website every month wanting to get into a natural house because they can't be in a toxic house. We have not had the developers step up to bat and take the risk in saying, hey, if we switch and we build 30 houses here with natural based materials that we can then sell as a natural home, a healthy home, they could sell every single one of them for whatever price they wanted to put on it. They are so comfortable right now with their margins on what they're doing with conventional materials that there's no financial incentive for them to go in a different direction. There's no financial incentive for them to take on that risk. Okay. And so that's the big problem right there. I was talking to another gentleman about this and he's like, I did the lunch and learns for the architects. And they're like, that's great. I did the lunch and learns for the engineers. And they're like, this is great. Didn't do anything to move the needle. And he goes, then I started to go directly to the consumer, the person that's going to live in that house. And he goes, we actually started to get projects, and so that's kind of our disconnect, and what would really help move the needle if there was some regulation around the toxins of the materials that we use in the built environment. If those materials became 50, 100% more expensive because we decide to put a tax on those chemicals because we want to phase them out over time, then the developers would be like, holy cow, this is a cost thing. We need to get into making these natural houses and we need to invest in getting our crews trained over. And we know that investment is going to be steep on the first 5 houses because of the learning curve. But we also know we're going to gain that back up in the next 20, 50, 100 houses. That in turn would create market demand for more nature-based products, which would then help the companies that are trying to get the financing to create those products to show that, hey, there's more of a market and investor, you can get your return because now we have a demand for it. I really want to be able to create some creative nature-based natural products, and we have the formulas and the systems and some basic prototype testing on all of them. But to convince an investor to invest $20 million on a startup company with no product sales, you're not going to find it, But if you can convince the investors group to invest $20 million on a product line that's going to be created to be used in their subdivision of 200, 500, 1,000 houses, well, now we've already started to show product sales because they're going to go into the subdivision that's going to be built, And so for the investors to invest in the company to make the products, now they're at a low risk because you can forecast how much in product sales you're going to make over these next 200 houses. And you don't have to worry about a marketing program to market those materials because they're already going to be used, they're already sold in that subdivision, and so they're already committed to. And so for that first 4 or 5 years, as you're starting to get that product line up and getting the training taking place inside of building the subdivision with those products, now in 5 years, do we have excess material coming off of our product line? that we want to try to sell to owner builders or do-it-yourselfers? Or are we making so much money because we've increased our efficiency on building these subdivisions that there's other investors that want to develop other subdivisions like the one that you're creating, And so that's where we get the snowball effect. And at the end of the day, if we could get some regulation around and some education around the carbon footprint of the building materials. There's a little bit out there with a beam calculator that comes out of Canada. Chris Magwood is his name, and he's got a beam calculator. And that beam calculator, you can plug in there the different materials that you're using, and you can get a carbon footprint at the back end of it. If we could get to the point to where we're measuring the carbon footprint of the materials off of the architectural spec sheet that they have for a house or a development or a building. And if your carbon footprint is over so much, now your permit is going to cost you more, so that we could get to doing some sort of regulation around the carbon footprint of the building to reduce your overall permit cost, then it would push people to look in that direction. Or like putting solar panels on a house. If you could get a $20,000 tax break for doing clay plasters over your drywall to help control humidity and temperature and create a better environmental space inside of it, there would be clay plaster installers, companies jumping up all over the place.
Right. Do you think that regulatory capture is a part of why governments have not leveraged regulation to prevent these toxic products from being used in building and from limiting carbon footprint of some of these materials in these builds? Or are we just not there yet?
Well, I don't think we're there yet. And unfortunately, pretty much 100% of the architectural programs that are out there are really not teaching classes around the carbon footprints and the toxins in the built environment. They're teaching more of, you need daylighting to meet this LEED program, or you need, to wrap the houses. And the architect programs are still about the Frank Lloyd Wright design, how fancy, how out of the box we can do it, instead of going and saying, in this 3-credit class, we're just going to focus on carbon footprint, and your task as a designer in this class is to design the lowest carbon footprint house possible, so that in that class in their school, they would actually get a course where it's like, hey, sure, we're doing all this other stuff, but here's another alternative, and what does that look like? That would be a great start, because at the end of the day, the architects are the ones that have humanity's fate in their hands when it comes to building.
Yeah, and I think that natural building is pretty far ahead in terms of that kind of thinking, because I know one friend who works with students. I'm not sure if they're architecture students or I think they're engineering students, but they work on different like sustainable designs. But I don't hear natural building materials coming up as much. So it feels like for the scalability of that to happen, there also needs to be more companies like you mentioned, the one here in Colorado that does the prefabricated hemcrete, just to make those available at a larger scale. I wanted to show this because it's not just about how they remove these toxic chemicals from the home environment. It's also about the aesthetic of the building itself and being in that space. So can you tell us about this project, the Spring Project?
Yeah, and I see I have a typo up there, but that happens with humans. This project is actually a temple space. It's a Ayahuasca temple that these private clients built. And it's called a dodecagon, 12-post, 12-sided reciprocating roof. So the beams, the rafters that make the circle, they actually come together and are tied in at the top to make a ring where the main rafters sit into it to hold the whole building up. On the outside of that, at the top of the post where the beam goes around, there's actually an 1.25 inch thick cable that goes all the way around the building to deal with the outlift. This particular client wanted it to have as many windows as possible between the posts, and so that's the Pella windows that we got that fit that space. And it's got hempcrete blocks down below the windows, and it's got a hempcrete block above the beams to where the roof is, and that is all adobe floors inside of it. On the exterior, it's got a metal tiled roof system. It's got an exterior lime plaster over top of all the hempcrete material, and it's a beautiful project. It was interesting to construct. The timber frame system was actually cut out of Rocky Mountain Joinery up in Colorado, up where you live, because it was an engineered timber frame. When we looked at taking on this project, I called a timber frame supplier that specializes in high-end timber frames, and he put it out to bid to a couple of his timber frame joinery contacts that he had around the country. Because me, as the builder on this project, I was like, I'm not touching this thing unless I've got an engineered stamp timber frame, that's got a structural engineer stamp on it with all the blueprints and everything on how it goes together. It is a beautiful building. It has, besides the hempcrete in the walls and the lime plaster on the exterior and the clay finishes on the interior wall system and the adobe floor, above the tongue and groove ceiling, we had to build another roof system so that we could get our insulation, our value for code in the county of Hayes County. It wasn't inspected, but you had to show the detail of how you were going to insulate it before you would get your permit. And we went with the hemp bat insulation. It was one way for us as a company and me as a company to say, hey, we're going to stick with our philosophy of using organic based materials and especially supporting hemp products so that we could help companies with product sales, because at the end of the day, that's what it's all about for the companies making those materials. And so it has hemp bat insulation, R30 in the ceilings. It's a beautiful project.
Yeah, it's a beautiful design. Do you know the square footage on it, roughly?
It's 36 feet in diameter across there. So, and it's got a little bit of a wing attitude. Yeah, so it's not small. When we originally started this, when we were in conversations, they were wanting 30 feet, and then they drew a 30-foot ring out, and they're like, oh, could we go to 36 feet? And I was like, okay, but you need to make a decision here because I'm going to send it off for engineering.
You just made it a lot bigger.
Yeah. And then they got inside and they're like, oh, well, this is pretty big. And I was like, yeah, so it's roughly 1,000 square feet inside there, 900 and some. And again, it's all adobe floor.
I've seen this type of roof structure maybe used for like a dome Gaia kind of builds. I don't know exactly what it was, but yeah, not nearly this big. So it's pretty cool to see it on this big of a build with hempcrete walls as well, and really big windows. I imagine that wouldn't be your ideal in terms of if you're creating this as like a home environment, you wouldn't want that much sunlight coming from like north and west.
Yeah, I mean, we did put a small AC unit, forced air unit inside of it. We've been telling this client that it should perform just fine. Open your windows, do not count on the air conditioning unit. And every time we're there, she's turning on the AC unit and trying to get the AC unit to do it. And I was like, it's still drying out. You're condensating moisture in these walls and everything, Open the windows, shut off the AC unit. But that takes active human intervention. And I had another natural builder, because they were getting some moisture condensating under a stairwell, and they were worried about some mold in there. And the first thing that other natural builder said when he walked in there to that building was like, well, you need to shut the air conditioning unit off and open these windows, and it'll perform just great. It was one of those things that the owner was listening to the conventionally trained architect who was his best friend. And she's saying, we got to AC, AC, AC. And the natural builders with the natural building experience are shut the air conditioner off, open your windows, and all of these problems that you're having are going to go away.
Right. And that is an aspect of natural building that we haven't really talked about, is they're meant to be inhabited so that someone is controlling that environment on the inside and constantly adapting it to, the sunlight, the air. Is that the same for all of your buildings, or are some of them able to be left a bit more alone and this is just kind of a standalone because you didn't have that ductwork and everything?
No, it's a systemic problem with natural builders that I talk to, is that they're
Right.
unconditioning the clients to the thermostat on the wall,
Right. Right.
at the end of the day. It can even be the people who understand that have natural buildings that I've built with before. They literally have a bedroom where they've got it cracked about an inch to an inch and a half. And unless it gets super cold, they don't ever shut that window, And they're like, yeah, it performs great. I mean, even in Southwest Colorado, down in Mancos, Colorado, and this was a papercrete house, so it's not like a true natural wall system, but it still had the lime plasters and the clay finishes and the adobe floors. It was 97 degrees, and they had 3 windows that were open like 3 to 4 inches in the house, and it was 72, 75 degrees inside of the house in the middle of the day in August. And I was like, oh, you guys have your windows open? And they're like, what's really beautiful, Tim, is that the more we leave our windows open, the better this house feels.
For anyone like myself who wants to learn more about natural building, how do you recommend doing that? YouTube videos, books, participating in workshops. What's the best way to familiarize yourself with this topic?
Bruce King, New Carbon Architecture, is a book that's a really good book that he's got. He's got a couple of those books out there. I find that he's really looking at that whole aspect of it. So looking up different sources and different books on it that are really focused on the carbon footprint of the natural building. If you want to get your hands dirty in the material, there are different workshops out there that people are putting on all over the country. Just remember when you go to different workshops that the professionalism and the experience of the people that are putting on those workshops vary dramatically, from somebody who's done a DIY program to doing it on their own house and stuff like that. And what you're going to learn during that will be focused on what they're trying to teach. The lower cost of the workshop, I find the less you're going to learn about the material. The really good workshops that cost several $100s for a weekend, those tend to be the workshops where the client who's putting on that workshop has done the research and vetting to hire a more professional person with more experience to teach that workshop. Going to different trade shows that are not green building orientated, because if you go to a conference that's about green building, you're just going to get the same old green building conventional stuff. If you go to like the Northern Colorado Hemp Expo that they have every year, there's usually a really good set of panels of people talking about lime or talking about hemp, and they're more focused on that natural building material themselves. The biggest problem is there are not any real conferences around the country that are a natural building conference that is just focusing on natural building. There's a natural building group that does a natural building conference in Colorado usually every year. They're not a bad source either for it inside of their conference, but also going there with the intention that you're going to get a little snippet of true natural building and a system, and it's going to come from that person's perspective. And like I tell everybody, don't take what somebody says as gospel. Don't take what Tim White says as gospel, Do your own research. YouTube channels can be kind of hit or miss, and TikTok videos, because they might be a do-it-yourselfer who's doing a project on their first time instead of a contractor who's done a number of different projects. And everybody's like, Tim, you need to have a whole YouTube video channel type of thing. And I'm like, well, that's great. Where's the project that I'm going to get paid on to build it in the first place? And where's the client that is going to be willing for me to stop our production and do segments on the whole system. I haven't found that client yet.
As you were saying, with the ayahuasca structure that you built, the owner not knowing how to control the temperature in the air in that building, even just getting an understanding of like, how do I live in a natural building? Or like what materials are available, or what is feasible. Or do you have any workshops coming up? I know you did one on clay plasters after the Crestone Energy Fair. Do you have any plaster workshops coming up or natural wall systems?
No, not at this time. I mean, I actually don't even have a project in the foreseeable future at this point in time. What makes it hard to do workshops and stuff like that if you don't have a project to do them on. There are a couple of different native communities and different companies that are talking about bringing me on staff and then creating them through there. That's kind of where I'm at right now inside of it. I love teaching them and I love doing all of that, but that gets us to the last thing I'll talk about here is that the biggest hurdle in natural building and trying to be a professional natural builder out there in the marketplace and just focusing on that has always been having enough projects to do that are not 200 to 300 miles away from where you're based. We did pretty good with it when I had my company in Southwest Colorado, down in Mancos, Colorado. But, we still had to take on projects up in Silverton, Colorado. And we still had to take projects on in Pagosa Springs. So we're still 2.5 hours, an hour and a half one way to get to the project to work on it. And those are really the limiting factors on running a natural construction company and trying to be a professional company, is that extra cost in getting there, which leads to extra cost on the project. And it's not that the project overall is costing more, it's the time and money to get people there and to get them back every day. And that has forced the natural building field to be kind of segmented off to the owner-builder projects or the do-it-yourself projects, And so that's always been what I've been preaching, is that we need to, as natural building, we need to get to that stepping up, like stepping up from green building to natural building. In the natural building field, we need to get to stepping up to 5-6 houses that are right in a row that we're going to build over a 1, 2, 3 year time period. Now I can recruit the people that want to learn about it, and we can move there. We have no problem moving as long as we've got 2, 3, 4 years of job security. And now our commute is down to 25, 30 minutes or 10 minutes. So it's just right down the block. Then we can really start to bring our costs down. We can really start to increase our efficiency on the systems. We can increase the education around the architect that's working on the project, the engineers that are working on the project. It opens it up to when we have 1 or 2 houses down, that we can have actually a show home, and we can open it up to different architects or engineers or green programs or lead programs to come out and do a site visit and actually get a chance to experience it, get a chance to experience the people that are living in those houses and how they feel inside of them compared to what they've lived in, which when you're doing projects that are hundreds of miles away from each other, that's not really even an option on the table to create those type of events.
I know it's been a long journey for you, so I appreciate you sharing your expertise. Where can people find you and find out about what you're up to?
We still have my old company, Texas Healthy Homes. Our website is up for the next couple of years. We've kind of branded that company out there, and so we've decided to leave that website up. It has an info at Texas Healthy Homes link to it that you can contact us. My personal email is Tim at TexasHealthyHomesRightNow.com. It is another way to reach me. And my cell phone number is 325-805-0607. And I'm always willing to take a call or a text message and sit down with somebody for, a half-hour introductory call. And then I've gone to, at that point in time, moving into exchanging emails, sending over a consulting contract or a design bid contract, so that we can start to work on design and start to put numbers together I've moved away from doing that for free to actually trying to get paid for it, because I've had a number of projects that have eaten up a lot of time and then they decide not to do anything. So in order to protect my financial stability, I found that I have to go in that direction.
How about, can people find you or expect to see you at any upcoming natural building fairs or events?
And not at this point in time. Send me a proposal and I will send you an invoice, and I am available to work on your project. The early bird's going to get this worm.
I think that's a good place to land it. I will include links to your website, Texas Healthy Homes, some of the resources you've shared as well in the show notes so people can easily access those. And I can throw your email in there as well. Thanks for taking the time. I appreciate it.
Yeah, you're more than welcome. And everybody's kind of concerned about where this next administration is going to go and the tariffs that they're looking on throwing on imported products. Well, a lot of the products that we use in the modern construction industry are imported. And so the price of those products will go up because the companies will pass them on to the consumer. The first hempcrete house, the Hondo Project that we built, those clients came to us not because they wanted a natural house. They came to us because they wanted to pay less than where the conventional market was with their materials. And so that's another hope that I have around natural materials is our materials are pretty stable because they're all made in the United States, and the producers of some of those materials are getting more streamlined, so their prices aren't going to go up, whereas imported plywood and drywall and paint and everything and the base ingredients that are being imported, those materials are going to go up. It's going to lead to inflation and everything too, but that is one of the hopes that I have with the new administration coming in, is that if the prices of these conventional imported materials start to go up and up and up, more people's developers and investors will start to look at how do we invest in local-based building products. And they don't really care about health and cost and health or anything like that. They're only cared about the bottom line of the dollar,
Right. That's a good silver lining.
Yeah.
I know about that.
Well, it's just American capitalism.
Yeah, that's good.
So, right on. Well, thank you very much, Alex.
If you enjoyed today's episode and found it insightful, please like the show and follow wherever you get your podcasts. A special thank you to the Crestone Energy Fair for providing hands-on workshops, tours, and panel discussions on natural building. The music for this podcast is Siesta by Ixon, part of the Tell Your Story Project, a library of free music for content creators. Visit ikson.com to explore the full catalog.